You know, we think about hormones as things that we produce in our bodies, but there are a lot of different ways of getting hormones into us that we may not think about. Stay with us as we talk about hormones, friend or foe.
Kentucky Health addresses the healthcare concerns of all residents of Kentucky and surrounding states. It was created by Dr. Wayne Tuckson, a colorectal surgeon practicing in Louisville. Here is your host, Dr. Wayne Tuckson.
Welcome to this segment of Kentucky Health. Today we want to talk about hormones. In particular, we want to talk about estrogens. Now, as we'll find out later, these are naturally occurring substances in our bodies. We make them. Women make more than men, and they're needed. Now, the problem comes in, what happens if we have too many of them, or are there different ways in which we're getting estrogens into our body? Chemicals that may look like natural products, or things that we're ingesting that may be in excess of what our bodies need. So this is what we want to try to talk about and get an idea. And we're pleased to have with us today Dr. James Whitliff, who is a professor of biochemistry and molecular biology at the Brown Cancer Center and with the University of Louisville, who is also the director of the Institute for Molecular Diversity and Drug Design, University of Louisville. You have a lot of titles, you do a lot of things, but you're the go-to guy when it comes to hormones, I presume.
Thank you very much.
I don't think I'm the only one who says that. What are estrogens?
They're the female sex hormones in a woman's body, and a man makes them as well. When a woman is premenopausal, she makes a very potent type of female sex hormone, but as she progresses in her reproductive life, she makes weaker estrogens, and these are made actually from male sex hormone building blocks in her fatty tissues, like in her thighs and her tummy and her breasts and so on. So that's how a postmenopausal woman stays feminine.
But you said estrogens ordinarily, though, are made
by the ovaries.
By the ovaries.
Right.
So if you take the ovaries out, no more estrogen.
Right.
Unless you have some of these fatty things. Now, I alluded to the possibility that there are exogenous or outside estrogens that we could be taking in. Are these the same kind of estrogen that a woman may make?
No, they don't look anything like the naturally occurring female sex hormones. They're chemically diverse, and yet they have incredibly high estrogen-like activities. And I'll give you a little example of the naturally occurring. We have a type of estrogen in horses, in mares. This is Kentucky. And the estrogens are chemically different. And a doctor many decades ago learned that a woman would respond to these and made a drug that thousands of women in Kentucky take called Premarin, pregnant mare's urine. That's an example of a mammalian or a natural hormone. There are also naturally occurring female sex hormone mimics, that's the word that we use, in plants. And as a group, that's called a phytoestrogen. And soy and corn and many of the foods that we take in daily have these mimics, and the emerging evidence is this is very good for us, even for men.
Is it possible that in that form we may get too much coming in if we're not aware that we're ingesting these things?
Well, one of the areas that's of concern right now is that children or newborns who are receiving large amounts of plant estrogens, it may be inappropriate for their developing physiology. So this is a sort of thing that scientists are investigating. Another type of female sex hormone mimic that's naturally occurring is found in mold.
Really?
You know, like mold that grows in the wall of your home or something like that if it gets damp. But these molds arise on damp grain, like corn and wheat and so on. And animals that eat these can in fact become estrogenized. That's a word that's used. And so it can stop their reproduction and give them the physical appearance of being pregnant, for example. If you consume those, then your body can respond to these, because in each of our target cells in our body, we have mechanisms to respond to the male sex hormones, the female sex hormones, and so on. So this is really quite a serious concern, and I've only touched on the naturally occurring hormone mimics.
What about some of the other things? I remember there was a concern many years ago about incidences of breast cancer. Were they related to the insecticide like DDT, and how that may act like a estrogen?
Right, and many chemicals used in agriculture, herbicides are used to control weeds, insecticides, and these sorts of things have man-made compounds that are called endocrine disruptors or endocrine disruptor compounds. Your audience will see EDCs written in the newspaper and in articles. This is a huge concern right now because these can alter development in animal populations, in fish populations from polluted streams, in city water supplies that don't purify the wastewater properly, even in hospitals where patients may be taking estrogen mimics as therapeutics. As a physician, you know tamoxifen and raloxifene, which is sold as Evista for treating osteoporosis. Many, many women are taking these compounds, and they're perhaps not completely metabolized in the body, and they may be excreted in the urine. And if the water purification system is not appropriate, those will show up.
Now, it's interesting. I was under the impression, or at least I wanted to believe, that if we're eating an exogenous, some estrogen-containing product, that in our digestive tracts, this would be broken down and it wouldn't be something we'd have to worry about. Now, you mentioned that animals may eat a food, that the mold on the wheat or the corn, and then I guess we in turn can then eat that. Will it still be active in throughout digestive tracts?
Certainly. Do you know what masa harina is?
I have no idea.
You like tortillas?
Yes.
All right, so that's masa harina is the hominy or the ground corn. Okay. And there are reports in Mexico and Central America where farmers in economically disadvantaged areas may be growing corn and store the corn in a way that it becomes wet. Fusarium molds grow on it. These compounds are very heat stable, and they may then boil the corn and grind it, make the masa harina, which is the ground corn, make tortillas, and be consuming it. And this has been reported. Other examples are animals eating the moldy grain. Take that into their bodies and appear, there are many, many reports of in the sow population, where a sow will have eaten damp, corn that's been contaminated by these molds as a result of being damp. And the mammary bed appears as if she's pregnant. Her external genitals indicate that she's under some physiological response, and it's totally estrogenization due to eating these molds in the diet. Well, think about it. That could also be transmitted to us. These are amazingly stable. They're fat soluble, so we would store them if we are overweight in our tummies, in our thighs, woman in her breasts. And the real concern is transgenerational effects. In other
What
words,
do you mean by, yeah, what do you mean
if
by
a
that?
woman is pregnant and she consumes some of these estrogen mimics that are endocrine disruptors, she could store those in her fat tissues, and then during pregnancy and lactation, these could be released, and then the developing embryo or fetus or the newborn could take these on. It's amazing the places in our body these are transported and the actions that they can have.
What about the, I think in the beef industry, purposely, and I'm not saying this to condemn or condone or give praise, but we use estrogens to fatten up the animals. Now, is that still, when we turn around and eat that animal, are we getting that extra load of estrogen then?
Decades ago, diethylstilbestrol, which we used in cancer therapy 40 years ago, was placed as pellets in the necks of capons. Capons are the castrated roosters.
Oh, okay.
To make these gourmet type fowl. That made a very meaty beast that was a high market price. But I'll give you two quick examples. In Canada, the mink farmers were feeding the chicken necks from many of these poultry farms to the mink.
Yeah.
And all of a sudden the guard hairs on the mink's fur began to get long, which is not what you want in a pelt. In the South, there were little stands along the road where you could buy a long neck of beer and eat fried chicken necks. And these men who were eating these, they would stop after work, meet their friends, and have one of these snacks in the country. Their voices began to become elevated. Their beards began to become silky. Yes, this was immediately stopped. But in the beef industry, they used to put pellets of DES in the neck to improve beef production. And to this day, there are estrogen mimics put into cattle feeds, but they're different kind of estrogen mimics. And the idea came from some of these toxins, some of these estrogen mimics in the moles. And there are companies here in the United States that still sell some of these products.
You know, and perhaps it's not a fair question, but as we look upon at least the increased awareness about breast cancer and perhaps even endometrial cancer, it seems like these are cancers we know are related to steroids. Is this one way which we may be increasing this problem in our communities because of this exogenous estrogens?
Well, I don't know about that, but if I could use your question to just illustrate how this can be exploited for the good of our population. Tamoxifen is a female sex hormone mimic that's man-made. It's a potent estrogen. It's used to the benefit of millions of women worldwide in treating breast cancer. If it's given in a small dose, it's an estrogen. But if it's given in the dose that's given therapeutically, it's an anti-estrogen. Hence, it kills many of the breast cancers. But with a very tiny risk, some women will get uterine cancer. So Eli Lilly got the idea of this, studied it further, and came up with a drug called raloxifene. Raloxifene was developed first as an osteoporosis treatment. It's sold as Evista.
So what's that? So to keep the bones from being brittle?
Right, to keep the bones from being lost, from bone loss in women as they go through the menopause.
Okay.
But then this compound raloxifene was put in a clinical trial with tamoxifen. And it's now shown that it is also anti-tumorigenic. So here we might have a way with a lot of these different kinds of man-made estrogen mimics to treat disease, to even perform what is called or practice what is called chemoprevention. And tamoxifen is now given to many young women who are at high risk for breast cancer due to their family history and so on. And it has reduced the incidence of breast cancer in this high-risk population to as much as 50%. It's a historic contribution. So estrogen mimics, you know, we have to be guarded about some, but others are absolutely very helpful to us.
Any role in cancers like prostate cancer?
Well, curiously, some prostate cancers have the mechanism to respond to female sex hormone. You're not old enough to remember, but a long time ago in medicine, diethylstilbestrol was given to men with prostate cancer. And it worked in a very low concentration. But the men responded to it, since it's an estrogen mimic, and began to get gynecomastia, which is their breasts began to develop. And so most patients, male patients, rejected this as a therapy. And we went on to other types of hormonal therapies, and now anti-androgen therapy is used routinely in treating prostate cancer.
Same kind of thing?
Same kind of an approach, but in this case, it's an androgen mimic.
Now, how different are these compounds from one another? The mimics for androgens versus the mimics for estrogens? Very similar or completely different?
No, they look very different chemically. But what's really curious about women, and I know there are many things curious about women, but one of the most interesting for us as scientists is that the mechanism for responding to female sex hormone is so vast compared to the mechanism for male sex hormone, for glucocorticoids, which are adrenal hormones, for the mineralocorticoids that control electrolytes and so on. The mechanism for responding to estrogens and estrogen mimics is based on two proteins called estrogen receptor proteins. And they're in the target cells of men and women. All right? But what's curious is that they're, I hope I may use the word, promiscuous. They accept the naturally occurring estrogens.
I see.
These man-made pharmaceuticals that will kill cancer, but then they'll accept other man-made compounds that, like DDT is a weak estrogen mimic, different kinds of herbicides and pesticides. Even PCBs have a low amount.
The things that for plastics?
Right. Bisphenol A in dental bonding, in plastic bags, in plastic water bottles. It's now recommended by the EPA that one does not wash these, you know, and reuse them many, many times, because bisphenol A can be leached from the plastic. I mean, and the EPA, the National Institutes of Environmental Health Sciences, and the Food and Drug Administration have new committees. I'm serving on one of these currently, to look at technologies for assessing these very quickly. Something as small as your pen that could be checked in the field, maybe in war zones like Afghanistan and Iraq, because they could be used in bioterrorism, because you could shut down the reproduction of a population.
Wait a minute, you're saying that theoretically, I'm not saying it does, but theoretically, because of the mimicking effect of some of these chemicals, it would stop women from going through menstruation?
Absolutely, just like these compounds I told you were in molds, and animals eat the moldy grain, their reproductive cycles shut off. They look as if they're pregnant or lactating, and they are not. And so there's a lot of interest in applications of these. We built, with a company in Michigan, have built a biosensor that allows you to test groundwater. The National Groundwater Association is very interested in monitoring these compounds. Many federal agencies are. saying that we should be monitoring wastewater from hospitals because we give so many of these things as therapeutics. Birth control pills. Many of the compounds in birth control pills are very estrogenic. And hopefully our water purification systems are taking care of those.
I know.
It's a really fascinating.
Well, as we look at, I notice that more and more communities are having where people come in with their medications to dispose of in a proper way. So I imagine there are many people just throw things down the toilet and figure that a wastewater treatment is going to take care of it.
No longer recommended.
Because there's a potential that this could be out into the water and just get into us.
Absolutely.
Now, is there a way to know that some of these chemicals may be in the foods that we're eating? Anything by looking at a label that may say, hey, you know, they're one of these estrogen-like compounds are present, so that we can say, okay, I want to stay away from that. Any way of telling?
Not on labels currently. That's something that's certainly being considered as part of many of these new panel reviews and so on. We need ways to detect tiny levels of these. We don't even know what the dangerous doses are. So there's a lot of research that's going on. In the University of Louisville, the Commonwealth of Kentucky has a number of people that are intimately involved in this. But one of the best ways to do this is to use the internet, because there's a lot of very good information that's in publicly accessible sites to do this, not just government sites, but different groups, because it's very interesting. These can be exploited for the good of man and man's health, and they can also be dangerous.
What about some of the foods? Let's go back to that if we can as we're wrapping up. I know soybean, again, high in the phytoestrogens, vegetable-like thing. What are some of the other foods that may have estrogens or estrogen-like compounds within them naturally?
Yams are rich in a couple of different compounds. One of them's diazegenin. Curiously, you mention it because one of the emerging industries in Kentucky is growing grapes and making wine. And I'm sure you've heard of the French paradox, where Frenchmen eat a lot of cream sauces and butter and, you know, a lot of rich fruit and so on, but they suffer fewer cardiovascular insults, events compared to American men. And one of the curious differences is their consumption of red wine. And it's now been shown that many varieties of red grapes and red wines have isoflavones and compounds like resveratrol. Resveratrol's a curious compound, doesn't look anything like a woman's natural female sex hormone. And yet it's a weak estrogen, and it appears to be doing good things. Well, where most heart attacks and cardiovascular insults occur in men. So now there are groups trying to develop female sex hormone mimics that will not estrogenize a man, but will be protective for cardiac problems in men.
You know, Jim, I'm going to raise a glass of wine and think about you, and now I have a good reason to try some of our Kentucky-raised grape wines here and know I'm doing something to keep me healthy and safe. It sounds very interesting when you look at different sources of getting some estrogens in our body, either from the insecticides, herbicides, we have to be careful, from our meat industry, from things that are given in order to make the animals grow, and then of course hormone supplements that people may or may not be taking. It is fascinating when we look at all the ways. I think if any one of you have questions about this, you should feel free to contact Dr. Whitliff's lab or contact your physicians or local public health centers to get more information, because there's a lot of stuff that's out there that are in our food chain that we may or may not be aware of. Not necessarily bad, but you definitely want to know about what's going on and what we're taking in. I want to thank you for being with us for this segment of Kentucky Health. Jim Whitliff, always a pleasure to have you around. Feel free to contact us at KentuckyHealthInsightBB.com. Thank you very much.